Hi viewers, welcome to LMS Solution. Today we are going to explore the detail of PV wind diesel generator connected with the residential load, as well as it going to be connected with the EV, and how that EV going to be operate in the vehicle to grid concept. So first I am going to explain the detail of about that system model. So here you see that right, PV array, right? So PV array, so it rated around 8 megawatt, okay. And then here you can see that, so this is a irradiation profile for the 24 hours. And then this is wind farm. So wind farm is rated at 4.5 megawatt. So here you see that this is a wind profile, and here you can see that this is a irradiation profile, and this is 15 megawatt diesel generator, okay. So this 15 megawatt diesel generator will be operate around 60 hertz frequency. And here we have residential load, so residential load as well as industrial load, right? So this is industrial load. So here you see that, right, motor going to be turned on at 3 a.m. okay. So that means, so here you can see the breaker, so breaker will be turned on at 3 a.m. okay. So that means, so based upon that, here you say 3 into 3600, okay. So that means you have to provide in terms of 3 a.m. means, so for 1 hour that seconds will be 3600, okay. So 24 hours, right? So 60 seconds equal to 1 minute into 60 minutes, so it will be comes around 6600. So here that motor will be turned on at 3 a.m. okay, at 3 into 3600 seconds, okay. And it has static load around 1 kilowatt, okay, at voltage around 600 volt, okay, 60 hertz. So here this is a residential load. So when go inside, right, residential load, right? So you see that this is a modeling of residential load. So it will be load going to be load, here you see that this is a load profile, okay. So load profile vary according with the commands P key, that means real and reactive power commands, okay. And here you can measure the detail of industrial load as well as a residential load here. So here you are measuring the real power, so here also measure the real power of the industrial load as well as residential load. So here you can see that this machine will be act as a water pump, okay. So that means we are taking the speed and taking the square, so speed square, and then it is given to torque input, so then it will be act as a water pump, okay. And here you can see the power output, rotor speed and torque of the that water pump. And here I am going inside, so here that so this is equation for the PV array, okay. So that means we are taking the irradiation, and then here we are mentioning the area. So here you can see that the input that means we are feeding the detail of efficiency of the PV array, and then area. So area is 8 into 10 power 4 meter square, okay. And here we are feeding the irradiation, and also here you see that, right. So this is for a partial shading condition, so you can enable that partial shading also, okay. That means here you see that, right, the partial shading is 12 hours. So here you see that the duration will be 5 into 60 seconds with the factor of 0.7, okay. So you can select the parameter, you can change the parameter, in that factor will be changed in between 0 to 1, and then you can fix the timing, duration of that partial shading, and then when it going to be start that partial shading, Okay, so it is showing that 12 hours. So you can change that detail also, partial shading, timing also. Okay, and then both will be multiplied here, and then it will be input for that PV farm, like irradiation. So here we are the irradiation multiplied with the area and then multiplied with the efficiency, then we are getting that actual real power requirement, that means power generation from that from the PV array. Okay, so here we are making that constant will be, that means we are taking minimum imaginary part. Okay, so finally we are getting that apparent power. Okay, so this apparent power for that PV model, PV array. Okay, so next you see that right here we are measuring the voltage across between two phases. Okay, so it's like a PV connected to the grid. Okay, so just you have to measure that voltage across that two phases, and also here we are measuring that voltage across the two phases. So here that equation is given, the equation is showing that, right. So V1, that voltage, right, which is 1 by 3 VAB minus A square star VBC. Okay, so finally we are getting the voltage. Okay, so next you have to find out the current. Okay, so we are finding the current. So for that we are going to use this formula. So that means here the current will be 3 into VI divided by 2. That means, so here this one is current. Okay, so this one is current, and so this is apparent power, so this is voltage. Okay, so we need to find out that current, right. So the current which is equal to, so 2 divided by 3 into multiplied with the S divided by V. Okay, so this is apparent power, this is voltage of that two phases, that means terminal voltage. Okay, so here we are applying that power, so we are getting the current requirement. So this current requirement will be used to inject the current to the system. So based upon the irradiation value, right, so the current will be injected into that grid point. Okay, so next move on to wind. So this is a wind profile I told, right. So we are receiving the wind, so that means wind profile. So here I am clicking that nominal power will be, we are fixing 4.5, and nominal speed will be wind speed will be 13.5 meter per second, and maximum wind speed will be 15. So more than that it will be wind power will maintain at to 4.5. Okay, rated is 13.5. so when go inside, right, again, so here you see that, right, we are calculating the apparent power. Okay, so based upon the wind farm control, so this is a wind farm control. Okay, so that means we are checking the wind velocity, whether it is in between that 15 to 6. Okay, that is an that means 13 point that means 6 to 13.5. Okay, that is an nominal operating region of the wind. So based upon that we are calculating the, so this is approximation power, right, that means converting wind power to that means wind energy, that means wind power to actual power requirement. Okay, so here we have that again apparent power. So again whatever calculation we did for V1, and then you have to apply this equation. So that means 2 by 3 S divided by V, then we will get the current for injection according with the wind speed profile. Okay, so here the condition is there, right. So we are feeding wind, the maximum wind minus 0.1, and then here same thing we are given here, right. So what will be happen, right, so this will be normalize that wind speed, and then they are going to check that wind speed level, right. So whether it is in between that 6 to 13.5 meter per second, and then based upon that it will be allow that wind detail. Okay, so here after that we are making V cube. So that means here taking V cube, that means the power generation from that wind. Okay, so that is proportional to the cube of the velocity v cube, right? That means power of v power of 3. Okay, so that's why here they are taking that cube of that wind, and then here we are converting that wind power into actual power requirement for that that means power generation from the wind energy. Okay, so next we go and see diesel. So this is a diesel generator. So here you see that this is a diesel generator for 15 megawatt, and it is having diesel engine governor and excitation control. So this diesel engine governor used to drive that this synchronous machine, and then this excitation will be used to excite the field. Okay, in order to generate the 60 gauge supply with 25 kilovolt that mean uh, line to line voltage. Okay, so here you can measure the power of diesel and real and reactive power. So next we move on to EV. So here we are using transformer, step down transformer with the 25 kilovolt to 600. So go inside. So this is 20 megawatt. Okay, 60 hertz. So we are stepping down that voltage from 25 kilovolt to 600, and here that modeling of V2G, vehicle to grid. Okay, so this is a model of vehicle energy conversion, and then here you see that this is a car profile. That means before that I am going to click this one, you will get some idea. So this is the power of rated power. So 20 into 2, that means there are two car connected in the system. Rated capacity is 85 kilowatt hour, system efficiency is 90, and so these are the some basic steps for that car profiles. Okay, when go inside, right? So this is a car, that means there are two cars connected to the system, so that going to be operated into V2G charging and regulation mode. So here you can see that so this is a model of that car according with the vehicle to grid concept. Okay, see that. So this is a state of charge control and charger controller. Okay, so this is based it will be fully operate based upon that model of that vehicle. Okay, so these are the explanation of this model. So here you see that, right? We are measuring V2G regulation, V2G charging. Okay, and then here we are measuring resistential load and industrial load, right? So that means it will be act as a load point. So this will be fully is known as a load. Okay, load in the sense that mean here we have industrial load as well as residential load, and this car also can be act as a load. Okay, when it taking charge from the grid point, when it's applying to the grid, then it will be act as a source. Okay, and here we are measuring the diesel power, solar power and wind power. So here you can see the full detail, all power detail, load, diesel, solar and wind. Okay, so I am simulating this model. So here you see that, right, the blue color line, right? The blue color line is total power generation, and that yellow line, right? So yellow line nothing but load profile. Okay, and here you see that red one is diesel power generation, and then green is PV power generation, and then this magenta color, right, is the wind power generation, right? So you will see that variation, right? The total power generation, right, so is higher than that load profile. That means y is higher than that load profile, means that means so that the system having some losses, right? In order to make that system balanced, right? So source should be equal to load plus losses. Okay, so that's why that load power is higher than that of the load profile load power. Okay, So this is a variation. So in this point, right, we are getting that partial shading condition, okay, in this point, okay. And also you can see that 3 o'clock, right, this time, right, suddenly that load is increasing, that because of that at that point, right, industrial load will be on, that means solar water pump, sorry, in induction water pump is turned on, right. So that's why that certain spike. And then this is variation of uh, PV, wind, diesel with respect to load power, okay. And also if you want to see that vehicle to V2G operation results, so here you will see that you can see the power of charging, right, charging power of the vehicle, okay. And then this is reactive power requirements. So here you can see the regulation, that means power regulation and current regulation, okay. That means this is real and reactive power with the VTG regulation. So here we have two things, so one is charging and this one is uh, discharging, okay. So this is a discharging profile, this is a charging profile, okay. So this is a simulation result of the system with the 24 hours vehicle to grid system concept, okay. So here if you want you can change any parameter here also, charging profile. So here that mean in this case, right, so here you see that you can number of car in the profile 1, profile 2, profile 3, right. So here you can click that, here the V2G is on mode, right, we can apply here and then you can see the result also without V2G on mode. So how the system is working. So now you see that without V2G mode, right, vehicle to grid mode, so you can see that variation, right, is not having the similar kind of response, okay. So when V2G mode is on, that response having different kind of response, that means so it will be operated according with the V2G operation. So if it is on, right, so the system, that the vehicle also can supply some power to the system, okay. So that is known as V2G mode operation. Thank you. Thank you for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you. Thank you so much. Bye bye.